Okay, so this is lesson 8 on rate laws. Differential rate laws look like this. The rate equals K times concentrations of the reactants, and a lot of times they are to different orders. Notice here, I don't have an order here for the A, so that means it is to the first order. Okay, so we're told in this problem that we have this rate law, and it has an initial rate of 1.2 molar per second, or this is also moles per liter per second, or moles times liter to the minus 1 second to the minus 1. All of these mean the same thing. Okay, so we're asked what happens if we double the amount of A. So let's see what happens. So if my rate equals 1.2, and all of a sudden my A goes to 2A. Well, what's going to happen is now my rate is going to be doubled, right? So I'm going from this to this, right? So my rate is now going to be 2 times what it used to be, 1.2 molar per second. So it's going to be 2.40 molar per second, right? Doubling something to the first order doubles it, right? So I doubled A, so this doubled. All right, let's look at letter B. In letter B, I triple B. So I have my rate equals K times A times now 3B squared. So notice my 3 is also squared. So what that means is my rate is going to be 9 times as big, or 3 squared is big, right? So 3 squared times 1.2, or 9 times 1.2 molar per second, and that's going to get me 10.8 molar per second, okay? Notice the units don't change because I'm just multiplying by some number. Okay, so let's go ahead and let's go on to C. So if I double A, I double the rate. B, I triple B, and what happens? My 9 times the rate. How about C? In C, I do both. I double the rate, or I double A, and I triple B. So now my rate is going to be K times 2A times 3B to the 9, square. So what am I going to do? I'm going to take that rate and I'm going to multiply it by 2 and by the 9, right? So it's 2 to the 1 and 3 to the 2 times my old rate. Okay? So that'll be 2 times 9 times 1.2 molar per second, or 18 times 1.2, which will give me 21.6 molar per second. Okay? So if I double it and it's the first power, it doubles. Second power, tripling will 9 times. And if I do both, I get both happening. So it goes up to 21.6. Notice rate is always in molarity per second. All right, so here it is on the screen. We can see that in each case, we're changing our concentration, and so our rate is going to change as well. Okay, let's go on to video problem 8b. In 8b, we have a reaction where we have rate equals K times OH squared. Where K is my rate constant, OH is my concentration of OH. So we're told some information. We're told the OH concentration is 0.05. The units for concentration are molarity, and we're told that the rate equals 0.00062 molarity per second. Right? Notice I put it molarity per second. On the screen it says molarity second to the -1. They're the same thing. All right, so now I could plug those in, but what I'm going to do is, seeing that I want to find K, I'm just going to rearrange this. Right, so I have K equals rate divided by OH squared. Now that I have this, I can plug everything in. 0.00062 molar per second. Okay. OH is going to be 0.045 molar. This is squared. Okay. So I'm going to do this. Break out the calculator. 0.045 squared. This gets me 0.00062 molar per second over 0.002025. I have my molarity squared, so this, the units is also squared, right? This goes back to first lesson of Chem 215. If I double or if I square the number, I also square the units. Okay, now when I do this, I get as an answer 0.31. And notice, I have molarity over molarity squared. That's going to get me molarity to the -1. And then I have seconds to the -1. Right? I'm always going to have a K that's in seconds to the -1 times something to do with molar. All right, so that's my K. Here it is on the screen. And that's it for video problems in lesson 8. Have a good day.